Welcome to video lesson 4.6 functions. Go ahead and put today's date in the top right hand corner. And our target for the lesson is that I can identify relations as functions and find values for function notation. So to begin our vocabulary, we have function. And function is a relation that has one unique domain paired with a range. The key word here is unique and domain. Unique means they all have to be different, so therefore they cannot repeat. And if you remember from our previous lessons, domain is our x values. So for functions, we say the domain, which remembers our x values, cannot repeat. Now the range doesn't matter. The range can do whatever it wants to. Domain specifically cares about the functions care specifically about the domain. Okay, so now we're going to look at what it takes to be a function. So for a relation to be a function, the domains cannot repeat. So we said that once before, but just to make sure we really got it, domains or x values cannot repeat. Okay, so as we said before, our x values cannot repeat. Remember, it's only the x values they care about. Y's can do whatever they want. Our second thing is it must pass the vertical line test for a graph. So if a relation is already graphed for us, we have to look at the vertical line test. If you think about the word vertical, that means it's going to go up and down. So if it has to pass the vertical line test, it can only touch one point at a time on a vertical line. So that means that the vertical line only touches 1 point at a time. And the keyword there is only 1 point. So if vertical line touches more than one, that means it's not a function. And basically that just means no points can be directly above or below each other, because if it's on a vertical line and they're directly above or below, it's going to fail the vertical line test. The very last thing is that all linear equations, that means all of our lines, using the variable y are functions. That's because your y value will keep it from being completely vertical. Okay, so let's look at some examples of this. Our first example says to determine whether each relation is a function. It'd be helpful to kind of sketch these out, that way you can see what we're looking at. First thing we're looking at is a mapping. We have one line going from our -4 to our 9, one line from -1 to -6, one line from 1, one line from 3. So once again, functions only care about your x values, and I only have one line coming from each of these. So yes, this is a function because there's only one line coming each x. So now let's go over here and look at our example 2. Once again, functions only care about your x values. So I'm going to come over here, highlight just my x value, just my domain, and look at those. So my domain is -3, 2, 3, 2. My 2's right here repeat, and because my domain repeats, it's no, not a function. When it's a no, it says to explain. So no, the domain 2 repeats. Okay, and our last example gives us a set of ordered pairs. So relation, the set of ordered pairs, and gives us -2, 4, 1, 5, 3, 6, 5, 8, 7, 10. So once again, it only cares about your x value. So I'm going to come across here. X is the first part of your ordered pair. So because x comes first, I'm going to come through here and highlight all my x values. So x is the first part of your ordered pair. So x is the first. So we're going to look at just our x values and say -2, 1, 3, 5, 7. They're all different, so they're all unique. So yes, it is a function. So our next examples are graphs. And with these graphs, we're just going to sketch them out real quick. So our example 4 is this U shape. And once again, if it's a graph, we're going to make it past the vertical line test. So I'm going to grab my vertical line here. Vertical lines, like I said, go up and down. So we're going to look. And if I scoot my vertical line across here, make sure it only touches one point at a time. So I'm touching one point on my graph of my U shape. It's called a parabola. I'm touching one more spot on the graph. So if I go through here and only touch one point at a time, then yes, it's a function. So let's come across to example 5. So pull my vertical line over to my next example. And as soon as I put it across my graph, I'm touching 2 points at a time. So that's automatically no, not a function. And because this graph fails the vertical line test where I touch 2 points at once, we say no, it's not a function because it fails the vertical line test. Okay, in our last example, 6, we're given a graph that has a closed circle and a line jutting to the left, and an open circle and a line pointing to the right. So once again, I'm going to grab my vertical line here, take it across. I'm only touching 1 point, so I'm good. Take it across this whole line, I'm still good. Now right here, when I cross over here, remember this part is an open point, and this one down here is a closed point. So a lot like when we were graphing inequalities on a number line, this closed circle means it includes the point with part of the graph. This point excludes it. So because this one's closed, this one's open, that means there's only technically 1 point there that actually is being used. The other one's just saying, hey, this is where I start, and then everywhere over here, I touch 1 point at a time. So because this one has an open circle and a closed circle, it's a yes. Now the next thing we're looking at is what is a linear equation. And wants to know if this linear equation is a function. And basically the easiest way to look at this is to say if it's in standard form and if it uses the variable y, it's automatically a linear equation. So I use the variable y, it looks like it's in standard form, so therefore yes, it's a function. Now, one more I'm going to put up here is going to be one that only uses an x value. And if it just has x equals 2, that means all your x values are 2, which means x repeats because all your x values are 2. So if all your x values are 2, that means it's no, because x is your domain and the domain repeats. So if it uses the variable y, it's automatically yes, it's a function. If it doesn't use the variable y, it's no. If all we're given is x, it's no. Alright, now we're going to look at what we call function notation. And function notation is an equation that is a function and can be written in function notation. So our regular equation we would look at looks like this right here. Y equals 3x plus 2. Our function notation writes f of x equals 3x plus 2. And all you do for function notation is you replace your y with an f of x. That's all that happens. It's still a linear equation. If you look, we have where we'd say yes, it's linear. The only difference is we replace y with f of x. So let's look at some examples of function notation. So example 10. Alright, we're given if f of x equals 2x plus 5, find each value. And then for part A, we're asked to find it for f of negative 2. So if you look, I write the function notation right above it, f of x equals 2x plus 5. If I replace this x with a negative 2, then that means I have to replace this x with a negative 2. So f of negative 2 equals 2 times x is now negative 2 plus 5. So 2 times negative 2 is negative 4. Drop down my plus 5. Negative 4 plus 5 is negative 1. So basically, we just use the order of operations to solve it. The whole left side kind of disappears. The only thing we care about is just solving the right side using the order of operations. Alright, part B says f of 1 plus 4. So once again, I'll match my f of x with it. I'm going to match up my equal signs and say f of x is 2x plus 5. So I'm going to replace x with 1, but this time I'm also going to tack a plus 4 onto the end of it. So 2 times, we say we now replace x with 1. Drop down our plus 5, and then at the end we're going to tack on our plus 4. So let's go back through and make sure we did this right. We replace x with 1, we did that, and then we tack our plus 4 on the end. We did that, we're good. Now I'm just going to use the order of operations, which means I have to multiply. 2 times 1 is 2. Drop down my plus 5, drop down my plus 4. Now we can do all of our additions. So 2 plus 5 is 7. 7 plus 4 is 11. Alright, and we're good for part B. Our last one is C, and it says f of x plus 3. So f of x, we said, equals 2x plus 5. And once again, it's substitution. So we're going to say our x is now a big parentheses x plus 3. So I'm going to keep my 2, but where it has 2 times x, I'm now going to say 2 times x plus 3 plus 5. Because I replace x with x plus 3, I had to replace this x with x plus 3. Alright, now we're just going to solve it out. So for this one, I have to distribute and say 2 times x is 2x. Drop down my plus sign. 2 times 3 is 6. Drop down my plus 5 because he's on the outside. Now combine like terms. So keep my 2x. I have no other x's. I can say 6 plus 5 is 11. Alright, that's function notation. Basically, function notation is just substitution. It gives you a value for your variable, so you replace your variable with that value. And you just keep doing that over and over again. And that concludes our 4.6 function video. Thanks.